Most earthquakes happen along the edges of the huge slabs of rock that make up the Earth's crust, the tectonic plates. But occasionally, instead of happening along these plate boundaries, earthquakes happen deep within the Earth's mantle, more than 700 kilometers beneath the surface. And scientists are still working on figuring out exactly why. So here's what we know about deep earthquakes. They mostly happen in places called subduction zones, where one tectonic plate is sliding under another. And they usually happen at the edges of these zones, not in the middle. And by deep, scientists mean like 300 to 700 kilometers deep, which is really deep. For context, that's about as deep as 100 American football fields stacked on top of each other. Now, the vast majority of earthquakes are caused by the sudden release of energy that has been building up in rocks along a fault line. That is, the energy comes from the movement of tectonic plates. But if most earthquakes happen on the Earth's surface or just below it, where does the energy for deep earthquakes come from? Well, one possibility is that deep earthquakes are also caused by the movement of tectonic plates. The thing is, though, that subduction zones where these deep earthquakes happen don't look like your typical fault line. They don't have the kind of sudden drop-off or jagged edge that you might picture. Instead, subduction zones are more like a giant, and I mean like thousands of kilometers long, ramp. So as one plate slides underneath another, the rocks at the edge of the overriding plate get dragged down this ramp. And normally, when rocks are pushed against each other, they will deform and bend without breaking, kind of like plastic. But if the pressure is high enough, they'll break, and the energy that was being built up will be released suddenly in an earthquake. And scientists think that's what's happening with deep earthquakes. It's just that instead of happening along the edge of the subduction zone, where the two plates are grinding past each other, the energy is released from deeper in the subducting plate, like in the middle of the ramp. But there's a problem with this explanation. Scientists can't actually see what's going on inside the Earth's mantle to confirm it. The good news is that there's another way to image what's happening deep underground. You see, when there's an earthquake, the energy travels through the Earth's crust in the form of seismic waves. And just like an earthquake can cause the ground to shake, these seismic waves shake the ground too. And by recording the strength and timing of those shakes, scientists can work out where the earthquake came from. One recent study used this technique to image the source of deep earthquakes in the Western Pacific Ocean. And what they found was surprising. Instead of happening in the middle of the subduction zone, like if the energy was coming from the overriding plate, the seismic waves showed that the deep earthquakes were actually starting deeper in the subducting plate, like down in the Earth's mantle. So it looks like deep earthquakes aren't caused by the movement of tectonic plates after all. Instead, they may be caused by the release of fluids like water from the subducting plate. When the plate begins to dive into the mantle, the intense heat and pressure hundreds of kilometers below the surface cause the rock to release the fluids it has been holding on to. These fluids then create pockets of low pressure, and when the pressure outside the pockets is greater than the pressure inside, the pockets collapse. And that sudden release of energy causes the earthquake. Scientists don't know exactly how all deep earthquakes happen. There may be different processes at play in different places. But one thing's for sure, they're a reminder that the Earth's interior is a dynamic and complex place. Thanks for watching this episode of Minute Earth, and thanks especially to our supporters who make it possible for us to bring you these short videos. If you would like to help us make more, you can get started at our support page.